my mouth because then it's a wet thing.
Oh my gosh, those grade 9 results are so annoying. Squishy.
You see why I feel the way I feel about grade 9s, right? Hey, just in time to be recording. I meant it. I'm going to send them the link. But you know what? All joking aside, it is human nature to want to lash out when you find something difficult. I can relate to that. But a whole lot of whining, not a whole lot of... So a whole lot of whining, but then when you say, oh, yeah, well, let's get together and I'll help you, all of a sudden the motivation to desperately want to know how to do these questions seems to magically fade away. You know, they're always so keen for your help when it's the questions in front of them and they go, he never helped us with this stuff. And then when you actually say, hey, let's come in at lunch and get help, then all of a sudden enthusiasm wanes. And that's okay. I seem to remember being 14.
Like, in my pocket, and I was just like,
Yeah, it was the time. Way back. It was the 90s.
we could have a
It was a different time.
We could have
Jeans were baggy and boys' hair was parted in the middle. And
No.
we angstily listening to all of your favorite Smashing Pumpkins records in your basement while complaining that nobody understood you. Because you didn't yet have Twitter to tweet about nobody understanding you.
Don't forget about the good old memory records.
Yeah, that was my experience. I'm sure that was many people's experience. So before we get to today's note, questions from yesterday's homework. Yesterday's material is pretty straightforward. Yeah, let's review. But did anyone have any questions from the homework you want to take up?
I didn't have time to do homework last night. I'm not gonna lie.
Well, that's okay.
I only do it when I find it hard, and I didn't find the lesson hard, so I didn't do it.
Okay, I respect that. So nobody? Okay, well, good. It was review material. Today we are going to move on. Do you guys prefer if I turn the lights out to see the screen?
I think so. We did that.
You interrupt my class and give somebody else something like that? You're terrible at this.
Oh, it's not to try to.
You don't know how this works at all. And then you're still interrupting. Get out of here.
Thank you.
Wait, but sir, Brad did his homework. Huh? Brad. Okay. You did.
Oh, I did it.
Purposely
I
making
did
your
it,
jokes
but
slightly
I
more
have no
separate
problem.
times.
I
Brad.
feel like you're just
Mr.
waiting to
Pitt.
give an actually good joke so that people laugh.
No.
Can we do the math?
I have never been more eager to do math in my life, actually. Okay,
I couldn't.
so today is another lesson on exponent rules. Today, however, is new. It is something novel, a new topic. So we're talking about rational exponents. That's the title. What's that mean? Rational.
Something that's
It's difficult.
Yeah.
something in accordance with logic.
True. That is one of the definitions of rational, though not the one we are using.
Okay, I don't know.
Though, in a way. Yeah.
Expressive number one.
Well, a rational number, they do include the whole numbers, so that's not the sense we're using it in here. Though the rational numbers do. Yes. The rational numbers are those which can be expressed either with a whole number, which is not what we're talking about today, or as a fraction. Any number that can be expressed as a fraction. They call them rational because using your rational skills, you can find the exact value of that number. Who can think of an example of a number that is not rational? All rational.
Zero.
Never mind.
Not a number.
Zero.
One you are intimately familiar with. You've used it
Zero.
very frequently.
Zero.
Rational. Oh. Yes. Aha. What number? Pi. No matter what one does, people have built computers that calculate pi to millions of digits. And it never turns itself into a lovely fraction by repeating. Because it's an irrational number. But rational numbers can all be expressed either as a whole number or as a fraction. Exactly. So in this case, we're using the term with reference to fractions. So a rational exponent would be an exponent that is, yes, a fraction. Very good. Now, how could that happen? I mean, obviously I could just write this. I could say x to the exponent, I don't know, a half. But what's that mean? Or does it mean anything? Am I allowed to do that?
I don't.
It's basically just saying x to the exponent of 0.5 or 1 divided by 2.
Okay, and what's that mean? Because an exponent means how many times you should multiply a number.
Oh, you have to
Right?
multiply the number.
So for example, x to the exponent 3 equals x times x times x. What does it mean to multiply x by itself half of the time?
Multiply x by half of itself. Like
Maybe,
that?
that is possible. What I want to ask is this. We reviewed some rules yesterday. Could I use one of the rules? Could I use one of the rules to maybe make this into not a fraction? What could I do? Imagine that I didn't want this to be a fraction. If I didn't want this to be a fraction and it was just a normal number, what would I do? If I don't like the number half, I want to make it a whole number.
You make the x a negative and put it on top.
Well, that didn't change the exponent though. It changed the sign of the exponent when we did negative exponents, right? It did change the base around, but the exponent stayed the same.
Invert?
Yeah, we don't know how to invert an exponent yet. But let's just say I have the number a half. What could I multiply it by so that it wouldn't be a fraction? 2. If I multiplied a half by 2. Now, is there an exponent rule where we have to multiply the exponents?
No.
Ah, yes. I could put brackets around this and then do what? Put an exponent of 2 outside. Very good. And if I did that, I would get what? Yeah, a half times 2 is just 1. So this would just be x. All right, bear with me here. Bear with me here. This is kind of a weird way to approach this. I wish I were exaggerating when I told you what I was about to tell you. I spent about an hour last night trying to think how I wanted to teach this concept in a way that made sense of it. I sketched out about 30 different ways. I hate all of them. I hated this one the least. This is my theory on how my wife chose me. I think it's not that she likes me, it's just that she could tolerate me more than she could tolerate the other men in her life. And she thought, I'll date that guy. Yeah, well, I don't know. This is my theory. So anyway, it means if we have x to the exponent half, we don't know what this means. But I know that if I squared it, I would get x. Ah, we have a murder mystery here.
Square root.
Oh,
Can you think of something else that if we squared it, we would get x? Yes. Ah, so if I square root x, and I did what to that? What could I do to that to make it equal to x? Yeah. Does that make sense? Here are two things, two ways we can square something and get x. I know that the square root of x squared must just be x, because the opposite of square rooting is
Squared.
square, the opposite operations. And if you perform opposite operations, you always end up with what you started with. Take x and square it and then square root it, you get just x, right? Just like if you take x and then double it and then divide it by 2, you'll end up back with x. Whenever you do an opposite operation, you get the thing you started with. So definitely the square root of x squared equals x. Now, because of the rules we learned yesterday, we know that x to the exponent 1 over 2 squared must equal x. Because when we do this, we have to multiply exponents. And now we're going to come back to my buddy Euclid. What is Euclid's first axiom? Talked about it yesterday. Euclid's first axiom.
How many things that equal the same?
Very good. Two things that equal the same thing must equal each other. So this equals x, and this equals x. They're two things that equal the same thing. So the first axiom of mathematics, as spelled out by Euclid, who is one of our fathers of mathematics. I'd point you to his face up there, but for some reason we just have 3 people up there. I assure you other people did stuff too. Euclid tells us that two things equal to the same thing must be equal to each other. So x to the exponent 1/2 must be equal to x square rooted. That makes sense? Again, a whole hour, that's the best I could come up with. This is why I should have been a plumber.
Hey, plumbers make good money.
Right? It's a great job.
If you work on a holiday. Also, you know, don't like your neighbors.
It's good to know, Tranny. Thank you. All right. So two things equal to the same thing equal one another. So that lets us prove in this case that x to the exponent 1/2 is the same thing as taking the square root of x. And I want to do just another quick trial. Would that hold true for higher exponents? If I said x to the exponent 1/3 cubed, that would still just equal x, right? You don't necessarily need to draw this. What else could I cube to get x? What else could I cube to get x? Not the square root, that wouldn't work, but the cube root.
I guess.
What is
Yeah,
that?
that's true.
I don't
I
know.
Evidently.
Listen. You're about to do the thing where you go, I swear to God, insert the name of person who's taught you grade 10 math, never showed us that.
Yeah.
And then I'm going to go,
Mr. Cutler.
yeah, you're right. He probably did. He probably just skipped that. And you know, a class did that to me once. So I had a guy I taught with named Mr. Prendick, and he was teaching grade 10 science for the first time. And he asked if he could have my notes for the chemistry unit, because he wasn't a chemistry guy, he's a physicist. So I gave him my notes for the chemistry section and the biology section. And I know he followed them note for note, because every day he'd come and ask me and say, oh, I taught this, and I'm doing this next. How do you set this lab up? I helped him behind the scenes, all this and that. So the next year I had all those kids in grade 11 university chemistry. And every time I got to a new concept, they'd go, I swear to God, Mr. Prendick never taught us that. And I'd go, yeah, he mustn't have.
Students with the bubbles.
He must have just skipped it. I don't get that reference. What's that mean?
Today is just not Andrew's day.
I'm sorry, I don't know what that means.
Okay.
Bubbles?
I'm not the way your voice sounded similar to a Ken Running TV show.
Oh, okay. Okay.
No.
Well, nobody's gonna.
Do I sound like SpongeBob?
No. Okay, I don't know if I'd still be in this class if I did. I mean, I love SpongeBob,
Who's the
but
pineapple under the sea?
SpongeBob.
Anyway, so there we go. Anyway, I assure you, you've seen the cube root. But don't worry, if you haven't, listen. If you haven't, that's okay, because we're going to talk about it today. By the way, what do you think it is? If the square root is just the opposite of squaring something, then the cube root would be the opposite of cubing something. So, for example, 2 cubed is
Cute.
oh, that's horrible.
2 times 2 is 4 times 2 is 8. So 2 cubed is 8. So the cube root of 8 would be 2. That's, see, exactly. It's just the number that you'd have to cube to get 8. It's the opposite of cubing. It's uncubing. Look it up. It's a word. It's not a word. Okay. So where this all leads is this.
It's not a word.
Of course it's not a word. You actually looked it up? Yeah, no. No, I assure you it's not a word. Okay. So here's the rule. When we have a fractional exponent, a rational exponent, this denominator is the equivalent of taking the root. That make sense? It's the equivalent of taking the root. So x to the 1 over n is the same thing as taking the nth root of x. If that was a 2, it'd be taking the square root. If it were 3, it'd be taking the cube root. If it were 4, it would be taking the quartic.
Somebody can do it by the way.
Quartic root? Yeah. No, you're not wrong.
Yeah, it is.
Quartic? No, that's real. You can look that up. You ask for a tan about that, it will come right up. Quartic means 4. So So anytime we have an exponent, that's the equivalent of taking a root. So let's look at an example down here. If we have x to the 1 over 4, that would be x to the... Yeah, you can just say 4th. You can just say 4th. It's okay. X to the 4th root. By the way, can I evaluate this if all I have in there is an x? No, that's just radical form. What about this one? See if you can do the next two. See if you can do the next two.
Why do you give us more food?
So what was the complaint? Because all I had but I'm sure there were words buried in that shocking amount of whining. And it felt like vaguely like my 10-year-old daughter walking into the room for a brief second.
Oh,
And yeah, I went there. Yeah, no, and I meant it. I said it, and I meant it. Oh, now it sounds like my grandmother. really covering the whole span of the Orlando family. Wow.
Apparently. Grandmothers,
Can we get into my dog Ruby? Can we get a bark? Anyone? No? We, you know,
What's the size of the dog?
Ruby's she's a shih tzu.
That sounds like you need help.
That laugh was
Are you making fun of my dog's name?
I thought you said Rudy, and I liked that way better than Ruby.
I like Ruby too, but she's a
Just
girl, so
rename.
She probably objected to being called Ruby.
Yeah,
Actually, she's a
the
dog.
dog would have some problem with me.
You wanted like the two.
My older brother was
Named this guinea pig Superman, no matter what.
Those are good. Now these, can you give me numbers? I bet you can. All three of those. Because the numbers. I bet you can evaluate these. Yep. Yep. Give me the actual number. So, so let's take a look quickly. So this will be what root? It's 1 over 2, so it will be the second root, or what we usually call the square root. And we don't normally write the 2, though you can if you want. And inside it is the 9. Can we evaluate that?
3.
Yeah, 3. Good. Good.
I thought it was my birthday. Yes. I was trying to cough and I was like, covered.
Oh boy.
What happened?
So are you ever exhausted after this class?
I feel invigorated after this class.
3.
What did you even do? I was being lit without even trying.
What?
You know, lit. Like lit, woo! You know, like
That didn't make it clear. to me.
lit, you know?
Just dab.
I guess it's like a
So, so this and this and this are all the same, and it's good?
Lit.
Okay, good, I got it. I understand.
Just because.
Don't worry about it.
It's like.
You have to say head.
It's not what I would say.
Will that make me very useful?
Because like I went to cough after I got the customer and I did it really fast and I just looked like I dabbed. And she was just like, "Did you just dab?" I was like, "No, I was coughing." And then it was like, yeah.
All right. I don't know, I found that so funny. All right, that's happened eventually. So, this next one, it is to the exponent 1 over 3, which means that we are taking the what? Third. What do we call this? The third?
I thought we were saying this.
This Orlando future cool.
This is devolving quickly. All right, so we are taking the third root of 27. All right, the fact that it's a fraction means we're going to take a root And the fact that it is 1 over 3 means that we're taking the third root. Yeah, so now that's the way ahead of me. But what number times itself 3 times equals 27? 3. 3 times 3 is 9, times 3 is 27. Now the good news is, if you have a calculator in front of you, just like it can... Oh, you know what's interesting? This terrible calculator actually doesn't have...
Hey,
Isn't
don't
that
blame the
fascinating?
calculator for your mistakes.
He didn't build them.
I wasn't aware I'd made a mistake. I mean, now, I make mistakes constantly. But at this particular
Do
moment-
it just by thinking of it. Just like 125.
Yeah, this actually wants fractional input, which is fine. Listen, most calculators have a button that looks like this, either root to the x or root to the n. These yellow ones actually don't.
Because they're crappy.
Is it utterly fine?
Oh, it's okay, because I'm going to show you how to do it on these calculators. I mean, this calculator just wants the fraction. It wants it how we see it above. Yeah, I don't see it. And that's okay, we don't need it, because we're going to know how to do the fraction. It's just an odd omission. Hello. Thank you very much. Can I see your calculator though? I bet yours has a... Great, so the way you would use that is... Oh, beautiful. And you got what as an answer?
3.
Excellent. Now the good news again with the calculators is, the calculator wants you to use fractional input for this, which is what we're used to, or what we're going to be used to by the time we're done this. So you just put in as 27 to the exponent 1 over 3.
The next one is super.
So what are we doing here? Our base is 125. We have a rational exponent, so that means that we're going to have a root. And are we taking the square root? The cubic root. So now what number times itself 3 times is 125?
5.
5 is correct. Good.
Also correct.
What makes no sense? Hmm? One of these days. It's just what I was thinking. Okay. Okay, last thing. Last thing.
For today.
What if it's not a 1 on top?
Oh no, then I don't know.
What if it's rational but there's not a 1 on top? Well, what do exponent rules tell us we would have to do with this exponent and this exponent? We would have to multiply them. So the answer to this will be x to the exponent 2 over 3 times 3. What does that equal? Sorry? 6 over, numerator times numerator, denominator times denominator, 6 over 3. Because if there were a number under here, if I were to write it, it would be a 1. And of course, 6 over 3 is just another way of saying, which is just 2. Yeah, let's not make our lives harder than they need to be. Life is so hard already.
I know. If I read good math, I try to
X to the 2 over 3 times 3. Of course, we know this. Dividing by 3 and multiplying by 3, those are opposite operations. Opposite operations always cancel one another out. So that leaves us with x squared.
Am I always going to work out with that?
This is just an example to show the idea.
You have
So
an easy example of your hard question.
So no. But just like last time, is there something else we could cube to give us x squared? What could we cube that would leave us with x squared? Well, what's the opposite of cubing? Not square rooting, but cube rooting. And what would have to be in here if the answer that was left over was going to be x squared?
What?
You're just saying words now.
He's desperate, guys. He's desperate.
I don't know it. I'm sorry.
Oh, I read
I'm sorry. I'm striking out.
You never went to the arcade in the 80s or 90s?
I'm sorry.
the movie Pixel.
Okay. X squared. Good.
Oh, God,
Okay, yeah.
no.
X squared. That's right, because the 3's cancel each other out. We'd have to be in there. Now, are two cases where we can cube something, and the answer is the same. And of course, what is Euclid's first axiom?
It's a ship. You get it.
Close, you're getting that. Two things that are equal to the same thing are equal to each other. So two things that are equal to the same thing are equal to one another. What are those two things here? Well, here we have x to the exponent 2 over 3. And here we have the cube root of x squared. They're equal to the same thing. So they're equal to one another. So again, what do we do with these numbers? X to the 2 over 3 is the same thing as x squared to the third root. So if we wanted to generalize that, we do. We do. Dear God. So we know that it's going to involve a radical sign. Where does the number on top of that fraction stay? Yes? It stays on the x. And where does the denominator of that fractional? That's right. It tells you which root you are to take. I think I can.
Can I just ask?
Sorry?
That is like
I'm so sorry. Give it to me again.
wait. Oh, I see. There's a bunch.
Okay. The other thing I'm going to say is if we prefer the mth root of x and put it to the exponent n, either one is true. These are both
goodness.
She's making terrible jokes.
The first one is the one we'll use more often, but both of those are mathematically appropriate. Yes, ma'am.
But on top, then we put the first one in brackets and then multiply it by.
I did that just as an example to show you that this works out to be the same thing as that, to show you that this is equal to that. So yes, I did put it to the same exponent here, but just to show you something we can do with it. That's not what we're going to do every time. This, on the other hand, is the general form. This is always true. So the top example is true because I chose to do that. I chose to cube it and see what happens. In this case, this is always true. X to the exponent n over m is the same thing as saying the mth root of x to the exponent n. Now, if that seems clunky or difficult, looking at some real examples is helpful. Yeah, or it isn't. I don't know, whatever. I get paid the same. So let's look at this example. It is a rational expression, which tells us that the answer is going to have to include a radical sign, which, by the way, is what we call this. That might be a term you're not familiar with. This is called a radical sign. What root are we taking? Which radical? Square root, cube root, quartic root, first root, second root? What is it? Yeah, the fourth root. Good.
Wow, that can I just say it. That sign is so beautiful. Like you do that really good. That was actually
Are you being sarcastic or serious?
no.
I can't even.
No. It's like genuinely. I think that is
Oh, thank you.
the most beautiful square root sign.
I don't know what's the most beautiful, but it's all right.
You just got a higher mark on your test, just like that. And you know, those marks have to come somewhere, so I guess, Avery, you're giving some of your marks to Dana. That's how that's going to work.
No.
All right, and what remains in here? X, and it is still cubed.
What the guy?
And we could just as easily, we could have also said that it was equal to the fourth root of x and then cubed. Sometimes one is more useful to us, sometimes the other one. And it occurs to me that that root sign appears to be turning into a bracket, which is less helpful. Yes, I did. That should be an equal sign. And that should be a bracket. And that should be a 4. I think we're good. next one.
Hey, I got all the answers down to the correct number.
Oh, did I do? Well, actually, let's leave it. Did I do that right?
No.
What did I do wrong?
No, wait.
Yeah.
So like this? Sorry?
Actually, you don't have frame two.
That's true.
Now you gotta answer the question.
Wouldn't it be like 1.33 or something?
No, it's not.
Well, I want you to, what's the other way I could write this?
You could do the square root of 9
Yeah?
multiplied by
Oh, not multiplied, but to the exponent.
the exponent of 2 and then the exponent of the answer.
Good, I could do that. Now, let's try working these out. This top one, what's 9 cubed? Dear God, use your calculator for that. What's 9 cubed? What is it? 729? And we would have to take the square root of that. What's the square root of 729? Aha. And that works. That's a good way to do it. It works. It's perfectly legitimate. What about if we did it the bottom way? Well, same thing, except now we do the bracket first. What's the square root of 9? And what do we have to do with that? 3? Not multiply it by 3. Yeah, we have to put to the exponent 3. We have to cube it. And 3 cubed is 27. So look, those are equally legitimate mathematically. They both work. Sometimes, if you have to do this on pen and paper, this way works nicely. Sometimes this way works nicely. By the way, if you're doing it on your calculator, it makes no difference. So,
The answer is on the side right there. It's black.
okay. And that's why the answer to this one is 125.
No.
Okay. She's cracked my secret code. That's what I do on all my tests. The answer to every question is the number of the next question. So like the answer to question 1 is 2, the answer to question 2 is 3, and so on and so forth. It always works a lot. I don't even want you to look at the questions next time. Just follow that pattern. It won't fail you, I promise. That's why the answer to 2A is B. Just, yeah, you're good. Actually, that would be amazingly fun. I haven't spent nearly enough time putting devious codes into my test questions, obviously.
Wouldn't it be the same answer for every question?
And then we have like at least like, so many multiple choice questions. They have like 1 page.
Yeah.
We have like a booklet, and she made all of theirs with the answers just B.
And yours were not.
No, they weren't.
And this upsets you.
A little bit.
I see
yeah,
that.
just a little bit.
I'm getting that sense.
That doesn't work because every question gives the same answer. So it's the same answer. Give the one answer to the answer to the next question. That answer.
Not the answer to the next one. I said like the number of the next question.
Oh.
Yeah. No, you're right. You're right. The other would just be, I just have to ask the same question over and over again, which is the kind of thing I might screw up and do, but it's not the plan. All right, let's try this one. What are we doing?
Oh my gosh.
Right? Yeah, today's flu.
They can't
Avery's having a lip gloss, and like, she keeps like staring at the
Can we just be very clear that science doesn't deny the existence of figures of speech and never has?
No.
It's okay. They're real. Yeah, they're allowed. It's okay. It's okay. Okay, well, this next one. How can I set this up? Ah. Ah. So the fact that it's a rational exponent means that I'm going to have a radical sign, in this case, the cubic root. And what's going to go in here? 27 squared. Or, if it's easier for me, I can also do this, but instead of putting the squared under the rational sign like that, I could also put it around like that.
I did the one that.
And again, try them both. See which one is easier.
Okay. There you go.
I'm the boy.
Yeah, very good. Yeah, looks like it makes sense too.
Oh, this person.
What? It's the same.
It's freaky.
No.
No, just no. How you doing?
So we won't do it again.
Good. Welcome. Fantastic. How'd that go? Nice. What was your biology test on? Yeah, that's good. Nice. I love.
Do you
I
like
love-
how we decorated his board?
You did a very good job.
Oh, her name's funny.
She's really upset that there's something to close. Did you want this one? No. Wait, thanks.
Yeah, don't worry. There's no good flavors left. They weren't worth it. They're not worth their tears. He's not worth their tears.
Just- Oh, dear God. Times like this, I think I could have been a gas station attendant. Right now, I could just be pumping gas, and I think, geez, that'd be nice. Just,
Your salary wouldn't be as nice.
well, you know, I wonder. Honest, I mean, I'll tell you this. I have yet to make as much money teaching as I made waiting tables. I'm still about 15 grand short. So I got a ways to go. Nope, no. Just checking. No, I
Waiter.
was a waiter, yeah. Yeah, and then I was a bartender and
Actress is a thing over some actor.
You're a
sorry? No. A waiter. Serving, waiting tables. I don't know. Yeah. So I don't know. I mean, it will be better. I guess I have benefits, and that's probably better, but still. But I'll tell you this, when I waited tables, I didn't go home and think like, what am I going to do tomorrow when I have to wait that table? I should spend hours getting ready for when that table comes in so I know how I'm going to bring them the food. Right? I just kind of went home and went like, well, work's done. That was fun. And so that was nice. I kind of miss that sometimes. But, you know.
When you go home now, you have to go, wrong.
Yeah, no, not with you guys last test for you guys. It was a very pleasant marking experience. For the most part.
And now you get to
Right.
have
Okay,
a
there's
red
one right there.
laptop while you are doing it.
Sorry?
Now you get the laptop while you're doing it.
That's right. No, all joking aside, I love my job. I do it for free, and I don't have to, which is better. This one here.
I'll tell the school board that. Joe would work for
You be
free.
quiet. So we're at this guy here. If we were to do 27 squared, what would that be? That's a big number. I think we already did that. Oh, we haven't done that.
720.
Yeah, and then the cubic root of that is what? Yeah, and I think a much easier way here is the cubic root of 27 is 3, and if we square 3, we get 9. Again, if you're doing it in your calculator, it doesn't really matter which way you choose, but if you have to do this with pen and paper, man comes up to you into the street, puts a gun to your head and says, solve this or I'll shoot. You know, I think the bottom one, That's a-
That's like this. I'll say shoot when we go
that's a
after
terrible
somebody. So I
idea.
got the gun to my head, and he wants me to do a math problem. Something tells me he's not going to let me go when I finish the math problem.
Are you kidding?
Something else that he's just gonna make me
If somebody had a gun to my head, and told me to do math, I would.
If English teaching job failed.
Okay.
Solves questions.
It's true. It could be. You got to draw the process out. It could be that he needs to solve the math problem or someone's going to kill him and he doesn't know how, so he's coming to find you.
Okay, where did
You
he
might
get the
be
gun?
you might
Why
be
doesn't he kill
you
him?
might be more used to him alive than dead. Is all I'm saying. Anyway. Okay. This one here. What do we have? Okay. That's a number.
Also, or-
But before that, how do we set it up? What is this? It's a radical exponent, so we're going to have a rational sign. It's a rational exponent, so we're going to have a radical sign. We're taking the cubic root of 125 to the power of 4. And in this case, I wouldn't dream of going the route, if I had to do it by hand, of trying to take the fourth exponent of 125. So it strikes me that this is much more logical if we approach this one this way. And what do we get for that? 625? Yeah, because the cubic root of 125 is 5. And 5 to the power of 4 is 625. And I think by only, you mean that like sadly, right? Yeah.
Again. Yeah.
This is actually.
What? You've taken this course, yeah?
Like not exploring these fractions.
Oh.
Like I've seen it play this question.
Oh. Well, we're going to explain how they work.
Let's not.
I stayed up for an hour last night to explain it, and this was the best I could come up with. And, you know, sometimes you judge how you're doing by the looks on people's faces. Give myself a solid C+. No tears. It was a tear-free experience.
I mean, well,
I hate the letters.
No, there was a
I
few
like the
tears. The laughter.
What?
The letters is 10.
But the letters can also make you feel like you're doing better.
I don't get it.
Because a B plus can equal
No.
75 or
Okay,
79.
never mind. There is
So
no
it's
homework.
I've never been more confused in one lesson.
There is no homework.
Is this, have you guys like ganged up? You're like, we find his math confusing, so we're going to make random statements that make no
No,
sense to
it
confuse
makes
him.
sense. If you listen to my struggle, it makes sense.
What's his struggle? Tell me about it.
The Timbits.
Oh, okay.
And then I said, they're not worth
You know they
your
don't
tears.
actually have names like
He's not
Tim.
worth your tears. And then she was like, oh my God, Tim, it was a pun because like.
Oh,
Tim
I missed that.
Hortons.
And then the laughter.
Yeah.
You guys are so funny. Okay.
Yeah, sure.
Or it's not what we did little tiny basic outfit.
Yeah, I can say, oh, sir, my home can't actually do
I
work.
have a bunch of them because of Chloe.
I want you to know there's nothing to puns, I just like them better.
Oh,
love
come on.
I just wanted to really
That's what I said. I
clarify.
said it was
Yeah,
good.
no, yeah.
There's so many.
He's right.
that I have.
But I think it says anything like, but my home can't work, so it's pointless.
So that one I liked a little better. We're getting there. No, that was better. I forgot to write the homework on the bottom of this note. Someone have a textbook?
No.
No, no.
Surely somebody has a textbook.
No, no, no.
I find them and I send it to her.
Can I borrow your textbook? Oh, hey, thank you.
So I had to give my textbook away or someone would kill me. So.
Yeah. Yeah.
Well, you better find it, or you might have the same problem.
That he had the exact same
Here's the
problem.
thing,
Somebody
right?
had to give it. He had to give somebody else a.
That's right.
So I just let him have it.
I can't get that.
Oh, I like this.
Do you guys know Sam Rutledge?
That I've ever studied.
He's a grade 9 kid. He's lovely.
I will talk to you.
Okay, anyway, he's a lovely kid.
You're
He's
better
really
not be
funny.
talking about my father.
That word.
Because
It's
not
not
really
really
named Sam. No.
Rutledge. No, then you're cool. You're good. I'll tell you, he's a really lovely kid. He's funny, but he's a very sincere kid. Today he was sitting there and he was kind of moving back and he stayed up and then he was looking at us and he was like,
Every time it's just like,
"This is
oh my
really
God, me."
inappropriate things."
There are some.
And then
I
he
just
was
can't
looking
go
around like,
over like.
"Those
Oh,
inappropriate
it's
things."
I was
It was,
like,
it was really adorable. It was really charming.
oh.
Don't
There
worry,
you
I
go.
got someone.
I wish I had gum. I just had.
Oh, no.
Mean things.
No, it's just like. Don't worry, I've got them right in this corner.
Page 170, numbers. Now I gotta pick this carefully because I'm doing it in a different order
Yeah. Her.
than the textbook. 'Cause I don't like the order.
I don't know. I don't like it. It's just me. Like I don't know. Like thunder thighs are like.
I was just thinking that.
I would have said I'm sorry, but I'm not 17 million.
Or I'm not 17 and I can't do this math.
Yeah, there we go.
Ugh.
What if I